we were linear. This is also the topic of this week, but most probably we will already progress to the right triangle as well. Because we've been going a bit like faster. Do you think that the pace has been okay? Yeah, it's been fine. Because many of these things, many of you already are sort of quite familiar with. Okay, this is in Finnish again.
Same pace later on may be a problem.
Yes, and it is. In the engineering mathematics too, usually the pace has been a problem. Now you already know because there's so many topics. There should be even more, but it's just impossible to. Then those certain topics should be already in this course, but well, not this year. And have you already done this quiz? Who has done the quiz? Really many of you have already done the quiz. And was it okay? Yes, it was okay. And now we started doing we went through all the material like those theory, and then we started doing these exercises. Yes. Who has done already all these exercises or the ones that they are about to do? Only one. Okay. Who is attending? And maybe the ones who are distant, that this is the reason why you're distant because, you this is a familiar topic to you, which I, of course, understand. Okay. So then the ones who already did this, you can progress, for example, to the right triangle. For sure that this is pretty familiar topic to you as well. Why wouldn't it be just like this? There's also the quiz. There's some theory and some exercises. And we will continue this lesson still with this linear equation and these exercises here, because then the ones of the quiz, of course, you can ask if there's problem. We can also look at those, but mainly with these. And I think we already progressed also on these to the exercise 5, where we were finding the equations for the slopes from these figures. Yes, I think this was the last thing that we did the last time. And then there is still quite a few exercises. So we will use this lesson to calculate this material through. And then the ones who are progressing faster, then you can progress already to the next topic when you feel like you know enough about this topic.
इतनी महंगी है, लेना ही अफोर्ड होती।
Yeah, this is actually what we did the last. It's the exercise 5, where we were finding the equation for the slope for the for the line. What have I written there? Oh, anyhow. And we progress to the C.
तो सेट हो गई है।
Okay, so please ask if you want me to calculate something here. And then I just check a bit what the, okay?
Okay. I don't think it shouldn't be. I never interceded, I took care of it. But, that's kind of meeting. Bye. You're gonna ask. See what it means.
Vielä tasan tuesta ei.
And then you have everything here.
Yeah. I can just sutata yli se kumittaa.
Mikä tämä on?
Siis se on niinku piirtoa läpi.
Onko se kai?
Niitä on 10 vuotta vanha, mutta silloin tämä maksoi jotain 50 €.
Tuossa pohjalla pitää ja se ei oikein. Se on siis.
Siis näitä on ihan joka paikassa, niin ne maksaa paljon. Meillä oli lukiossakin niin matikan ja musiikan päivillä tämmöisen. Ne ei tehnyt enää mitään vihkoja, vaan kaikki vaan tuonne luonnolle ja sitten ne jakoi ne tiedostot.
Joo. On nähty mielellään tekin siinä vannouksia, mutta kun se tuolla yhdellä piirteellä on niin tosi. Joo, meillä ei ole ilman keli. Ai. Ja sitten se on tosi ikävä, kun on itselläkin niissä luvulla. Niin sitten niitä pitää aina mittaa. Miten tämä se?
Tässä on vaan ulospäin. Nykyään näitä on laulettu vaan.
You already conference. So have you already calculated? Okay, so we calculate all that resumes. What?
but it's better for the region than the exam.
Okay,
Yeah,
so are you gonna do that?
yeah,
Okay, great, so you calculate the second here.
yeah, I remember the least. Well, maybe more actually, I thought it was 7.
Yeah, because there's like quite a many exercises still left. Also these like written exercises. Did you do those?
No, I've only done the first page.
This first page. Yes, yes. Yeah, so we are supposed to do a little bit more here as well. Just like something like a bit like thinking as well.
Yeah.
Because this we didn't really do yet. So that you should try to make your own equation from something. Okay. Okay, so I will calculate something here and you can do what you want. You can either follow or or do on your own pace. Because you are all doing, you know, I'm sure you're doing like really well on your what you need to do. But as we went through these, so then I will just do a couple of more simple things and then continue, for example, the 6 and 7, then continue to these ones here. And then there's also these written exercises. So then I will also do a couple of those, yeah? Okay, for example, right. What? So there was the 6. Find the equation for a line that goes through points. Draw first. Why not? So I would go to 3 and 4. So of course, 1. It's always with 1 and so on. 3 and 4 up. And then the next one was 4 and 7. So here would be 4. This was 3 and here was 4 and 7. Would be there. So this would be the 3, 4, and this would be the 4, 7. There would be a line. Then I would calculate, for example, the core that we mark with core. That was the change of y divided by the change of x. So here the change for y would be, it would be 7 minus 4. And the change for x would be only 1. So 4 minus 3. So obviously we would be here, we would get here 3 divided by 1, which would be 3. So now I would know that for the line, the k would be 3. And the equation for the line was well, it says it here as well, but maybe I'll still, because I have always this book with me, I found it here. This is what I was after. Or then, so y is kx plus b. So I would know now that this would be 3x plus b. Okay, and how about the b? Well, I didn't really draw this really well, did I? If I wanted to get it from the figure, so I could maybe do it. And then I would just draw it. As long as I'm doing it accurately, I will seem to get the to be also here. So here we would of course go -1. Oops, what am I? Right. -2 and so on. So we would be here in -4, yeah. So it looks like my is in -4. Did I draw it badly?
Hi, ma'am.
Is it something?
How it could be B?
Wait.
If we
Yeah,
write it
if it's
down,
here
then
in
it would be minus B, minus Y.
-5.
Minus Y, how it could be B?
Yeah. I think I did something with the drawing. The drawing is not easy. What did I do wrong?
No, I'm saying that if we write it down like it would be minus Y axis.
What?
Like if we go straight upside, it would be positive Y. But if we go downward, it would be minus Y.
-5. Okay. Yes.
Y minus.
Um,
No, I'm talking about axis.
I just can't see what I did wrong.
No, ma'am, I'm saying that how we can write it down like B.
It's
If
a
we go
pity that I
upward,
really don't hear. Maybe I'm like quite technically retarded when I can't use, I don't know why it's so difficult to hear from this. I should have maybe some kind of maybe from here I can do something. Okay, try to say something more now, please. If I can hear better.
no, ma'am, no problem.
Didn't help. It's like was. Okay. I don't know why I can't hear from this anything like. Okay. But I will check now what I did wrong here. I think I did something wrong with with drawing because now if I would calculate this, so I got the K correctly. Yeah. Mhm. Okay. Then if I would calculate this with this other form, so I calculated with the, I don't trust my drawing and I calculated with this. So I write there y minus y1 is this by 2 minus y1 divided by x2 minus x1. And this was of course the K here. This is the K. So then I put the 3 there. Y minus y1 is K times x minus x1. Okay, so then I need one point from the line. So I say that my y, okay, the other way around. My x1, y1 is the 3, 4 there. And then I put it there, so y minus 4 is the 3 times x minus 3. And I calculate from here. So, for example, like this, y minus 4 is 3x minus 3 times 3, which is 9. And y, and then I just add the 4 to both sides. So there would be 3x minus 5. So it has to be minus 5. So this is the B, and now somehow I can't ever trust when I draw something. What did I do? Something weird. How is it possible? Very weird. Somehow I just managed to put it has to be that I managed to put this in the wrong angle. So obviously by calculating, you get better results. Is it possible to draw it the other? No, I can't. I'll try again when I know. So if I know that it has to go there, yeah, it's possible. I just tried. The wrong way. So even in this kind of small, like that it's quite close, it's still possible to do a mistake of one. Thank you, by the way, even if I can't hear anything. Don't ever draw anything. Only with GeoGebra, because that doesn't make any mistakes. So then the next, where you have to calculate something like this. It's just an example what this means. No, it was the F with 2, 0, 1, and it is like this. So what does this, this is just to show you what this means. So it just means that if this is here, because this is now with X, so X is here as the variable. So now you just adjust a number there. Just like this. So now there's no X, but there's the number where there was the X in this expression. Okay, so 2 e power of 3 is 2 times 2 times 2 plus 2 plus 2. So it would be 12, yeah? I don't even have it there, whatever. Then if there's 0, then there would be 0 in power of 3 plus 0 plus 2, which would be only 2. And exactly, of course, the same thing with the 1. 1 in power of 3 plus 1 plus 2, which would be 4. Because it doesn't matter. 1 you can always multiply with itself, but it doesn't do anything. And then what is this? This is not a linear function, so we should then check what it is. Quickly. Maybe I have to do it like this. Shows that. So this was the tool that you can always use. And you can just write there this. Oh, it was the plus X. Oops. Not like that. Plus 2. So it looks like this. So it's not a linear function. it's a third degree polynomial. Working. So anyhow, if you want to make curls to a line, you should just put some power to the x. It's easier than with the girls with the hair, curling the hair. Just that was very funny. Yeah. Okay. Very funny, but that's how it looks like. And no more about that. So here we talk about the polynomial function. This is again exactly the same exercise, the polynomial function then. Whose graph is this line. And then there's many ways of doing it, but don't ever draw it, just calculate. And then when you get something out of it, for example, here is the same, I got the polynomial function. So this is the line that I got. Y is 3 times x plus 5, and then my function is here fx is 3 times x minus 5. Function of x, and it's the first degree polynomial. So we can have a more official way of describing it. First degree. We can just name it in a different way. This is a third degree polynomial. This here. Third degree. No. Why not? So the same exercise there, I'm not gonna do it again. You can still practice if you need. And the next one is the same again, but I will just do it quickly. And I think the next one is the same. So it's just to get you familiar with the concept of polynomial function. What does it actually mean? I have done something else there, so. Nine. Slope. Slope meant that when I have this here, the k is the slope, which in this one is -1. So now I already know minus x plus b. Okay. And then passes through a point. So I know that this 2.3 is on the line, or the line passes through it. And then I need this expression from here, y minus y1 is the Well, this y2 minus y1, this is from the technical formulas, how it shows it, which was the slope. The k, which is the slope, which we already knew, and then there was the x minus x1. So now I already knew that there would be, this is replaced with -1 or just minus. And here is the x minus x1. And my x1, y1 is the 2.3. And I can just put it there. So this is always the y, this is always the x, 3, and there the minus, and x minus 2. And then just, well, okay, let's do one more. Did I come? Okay, so y minus 3 is, and now I have a minus sign here, so there's minus x plus 2. So this, of course, this minus sign, it changes the signs in the brackets when I remove the brackets. Yes, this is something that you're familiar with. Yes, good. And then the final thing, I will want to have the y only here, so it's in the solved form. I solve it for the y. I have to get rid of the 3, so I add it. So if I add it, there's -3 plus 3. It went away. And here I have the +2 plus 3, so it would be +5, of course. Just like that. Okay, and the polynomial function, first degree, just write it like with the fx. And now we are in the final form. So exactly the same thing that we were doing, we just name it in a bit different way, and we write it more official way here. Which means that, of course, you have on the y-axis, you have, if I write it here, also in GeoGebra, could I write it like this? Y is minus x plus 5. Okay, I seem to have there's still the curve. And there's the line. I didn't get rid of this curve even if I took it away. Now if I press like this, it says f. So of course it wants to write it with f, you know. So here is the fx. Oh no, it just gave it the name maybe. Now and then now the curve went away. Fx on this, so the variable that depends on the x that is on this line. And this line, so here is the variable that you give values, and here is the function. And of course in physics, then you don't have x and y, but you have some other letters that depend on each other. For example, time and velocity or something like this. Okay. Quite simple, yeah? Who thinks this is really simple?
When you do it, very simple.
And then the 10 is the idea in this. Okay, again, the same thing. And if a point is on that line, should I do that through as well? Maybe not.
Well. Which one did you say? Sorry?
10.
You did it.
Yeah, fine. Yeah, of course. I'm a teacher. I love my voice. Why would I be a teacher otherwise? What else would I do rather? Yeah, so of course, well, slope in our, so again, we know that we are talking about the first degree polynomial function, which is this, the equations that we found from the technical formulas, and more officially, it looked like this. Where we would know that K is the slope, which is in this 0.4. Okay, so now it wasn't, how would you call this kind of number? This is a decimal. Yeah, okay. So we know this now, and then we know the other form, which was this, where we had the K here, which was I'll just write it as a K. And on the other, then here, this X minus. This is also from the technical formulas, but here you have even the expression for the K, which is the y2 minus y1 divided by x2 minus x1. Yes. So this all you find from the book that is now your best friend. Yes. So I would have put this there, but I don't have to do it like this. I can already put, of course, I know that the y1. Why do I always want to write the y first? Because it's there first, yeah? But x is always the first. This is also the way this language goes, yeah? It's almost always the first. There's the x coordinate, and the second is the y coordinate. Okay, so then I just have to put it there. So I would know that here, I put this, and then the other one was the first one here. I put it to that place. So here would be plus 12, 0.4, and then x minus 700. So this already sounds like this is actually some line that has something to do with something in the real life. Yes, because everything is not so like 1 and 2 and 3 and whatever. It's really rarely like that. Yes. Okay. Maybe you even talked in the physics with Jaakko about something like, maybe you have you used this kind of equations there, or try to model something that follows a line or dependence is something similar. Yeah. Okay. Well, I think I have this also here. I will also open the solutions for you. I have to always check, because I could also really easily make, like you can see, I can really easily calculate something wrong when I'm explaining here. Okay, this is not so easy to calculate this wrong, but I won't. Plus 12 is 0.4x minus, so 0.4 times 700. I should calculate it in head just like that, but I don't. you know, this is really easy. It's just 4 times 7, yeah? And then you have to, but I don't trust myself. It would be different if I would be only teaching maths, but I teach my head is full of many things, so then I can't calculate the simple things anymore. It becomes difficult. Okay, so this is minus, and there, oh, this is also a minus, isn't it? So I just add it. Now I was about to make another mistake, so I have to take it off there, yeah? So there it will be, this I'm able to calculate now in my head. It was so simple, yes. Okay. And then I want to have the polynomial function, so I just write it with this kind of expression. And that's it. And then I wanted to check if some point is on this line. So there's my function. This was the part A. So now I would want to check if this is on this line. Because, okay, I can't really, well, I can draw it with the GeoGebra, but then it might still be a bit difficult to actually see it. So how can I calculate it? So of course, this was the X, and this is the Y. I know now if this is on that line, then I would have to know that it follows this dependency. So it is what this means. So this depends on this. Yes. So if I adjust this here, it should give me this. Yeah. Yes. So I will even write it the official way now here. So I adjust this number there. So that is my X. 0.44 times this number. Minus this number that was there. And this has to be minus 378. Yeah. Do you see what it means? Okay. So is it? Let's check. And now 0.4 times, I don't think I maybe, well, I don't know if I have to put the brackets with this calculator. Maybe. Yes. Well, almost, but not quite. So then I got here on this side, I calculated it, and I got minus 376. Well, I had already put here this. So then I would put this kind of sign there. So it means that it's not.
Yeah.
It's also what it gives you when you write the things in the stack. Yes. If you write another line, you have one line and the other line, and it checks if it's the same. And then it says that it's not the same. Yeah, well, you've been writing this. It says that, okay, this expression on this line is not the same as on this line. But yeah, okay. Here we can just, when we write by hand, we can put this kind of expression. It's not it. It's not on the line. Almost. But for sure, if I would have drawn it, I would have got it there.
Yeah.
Easily. Just like that, it would have been there. So then this is some kind of a dependency of something, and then you know if you have to check if some kind of a thing follows this dependency or something. You know, this is in the real, for example, physics. Then we still have these ones to go. Do you want to also have now, I can put this, because there are the solutions. I have to put it like this. And oops. So they are hidden. I think they might not be in correct order. That I just think it looked a bit difficult. Maybe there are some different numbers for the certain exercises, but at least there should be show the solutions to all these anyhow. Then you can also say if it's unclear. Did I have also? Yeah, there's something also done with the with the AI. Most are done by hand from the previous course. Most probably the ones done by AI are more clear. Please ask if you need help or something with something else as well. Oh, there's 2 times the word was. Maybe you understand still what is said in the exercise 11. Do you understand what it means?
Yeah. Over and out longer.
I think this is not maybe the correct expression, is it? Water tank was and was filled. Maybe like there it is lacking one word.
Yeah, no, makes sense.
Okay.
Yeah.
Somehow to me it doesn't. I don't think it's even the solution is correct to this sentence. One quarter full. Oh, it is. It is. Yeah. It's really difficult to understand it in English. Oh.
second year. Add it. So the, or the addition. Okay. Yeah, I would. Add it, no, no. Oh, of course. But. And then remember also that the exam, the written exam will be based on this kind of exercises that we do here by pen and paper, not the ones that you do on stuff. Because those ones are sort of tested there. And then the exam will be sort of more complicated or something. I don't know if these are complicated or not, but of course, in the written exam, the exercises will be something like this. And not like the ones with simple solving, because that's what you already do there in the stuff. It didn't make much sense to do it then there again. Yeah. So if you only like concentrate on those, then also this is something that you should also do. Okay. So do you have, should I do one of these? Are you finding them easy?
The triangle, very. Why is 12? 12 is just why is that? I don't know.
The what?
12.
12,
Some
Yep.
just calculating.
this car.
Yeah, but you're just calculating the.
Yeah, it's super easy.
I-
Yeah, maybe you're wondering why.
So like, from my understanding, the linear functions is straight line. But you're just calculating speed.
Yes. Okay, well, let's Okay, 12. And there a car travels 60 at 60 kilometers an hour. So this is the velocity, obviously. So it's the 60 kilometers in an hour. Equation for speed is also this, which is also for sure you've seen this in physics. How far it will travel in time is 3.5 hours. So then how far? So it looks like you have this kind of simple equation here. So now you have been given the value for this. Yes, there. It's that. And you have been also given the value for this. It's there. So obviously this is what you need to know, even if you don't know that this means the how far, because this is the only thing that you don't know. Okay, so then you solve this. So you have this, for example, you would have moved it like this, and then you would have multiplied with t, yes? And you also know this for even by thinking, you wouldn't even have to maybe do this kind of thing. 60 kilometers an hour, and then you have 3.5 hours. And then also it looks like you easily get these units to work. You just get the kilometers out of this, which this is okay. I can calculate this, but I won't do it. And then you get that you went this would be actually quite horrible, wouldn't it? If you would have to travel with 60 kilometers an hour, this kind of distance. Okay, and then you can also, like, why is this a linear equation? If you draw it in the like this, yes. Yeah, and then here you have the S, which is now kilometers an hour, and here you have the T, which is now hours. Usually in physics you have it in meters per second, yes, but here you don't. Okay, and then you knew that you traveled 3.5 hours, so let's say this is, and there's the half. 3.5, it would be there. 1, 2, 3, 3.5. 3.5 would be there. And then okay. Well, you know that in 1 hour you go 60 kilometers, yeah? So maybe it would make sense to make this 60. Maybe this would be 62 hours, you would be 120, and 3 hours you would be 180, and 4 hours you would be 240. But then you wanted this here in between, yeah, which was the 210. 210, and then we could try to draw this here. This is not super accurate drawing, I might get. But like it is actually super accurate drawing, because I can go, if I divided this scale like this, I can go just like 1. So then it comes there in between, yeah. because this was, if I would have divided this in a different way, maybe I would have got it less accurately. But this, as you see, this is an equation of the velocity in a function of time. Yes. Where we can calculate, for example, we know that it's the change here, you know, if you calculate the k here, it's this changes, well, it's the change of y or change of s in the we divided by the change of t, yes, obviously. And the change, for example, if we take one here, we already knew it also from here, but it's like it changed 6 with 1, 60 with 1, yeah. So here our k, when we divided this, yeah, it would be 60. So it would be 60. And when we are in this units, then you calculate the t, yes. And then the intercept here is at 0. So then you won't put this, you know, +0 or nothing. Yes. Interesting. Who thinks this is interesting? But this is something that you do with Jaakko, yes. You measure something and maybe you even draw some kind of graphs of it.
Yeah.
With some kind of a program.
Yeah.
What would be the program?
It's-
Excel.
yeah.
Yes.
Yeah, it's very good. Thank you. Is this level of math like, you know, painfully boring for you, or?
No, I think it's no, definitely not. I think this is actually great because this is actually practical.
Yeah.
In this school, the level of maths that you need is this. In like, I would say 90%, at least 90% of your tasks.
Yeah.
As long as you're able to work with the letters, what they mean in the equations, or you actually understand what's happening there and what kind of equation you find from this book, or then something a bit more difficult. So there's maybe more letters and more maybe numbers, but the maths is this simple. Yeah.
Yeah.
So why would you go further? But after Christmas, we will go further anyway. And then and in some kind of modeling, you also use those equations. So that's why we have to go there. But I would say it like this is mostly the level.
Yeah.
Yeah, I'm happy that I teach anything like well more. This is a good level. I'm even here I'm able to make mistakes. Look, this drawing there. Where is my drawing? It's not that simple, is it? Here when I'm teaching like the thermodynamics as well, the calculations are just as simple.
Yeah.
You know, but you just have to know what the letters this. You can still do something there. That's not correct. Mm-hmm. Mm-hmm. Thank you. Thanks also that you corrected my drawing, that you said that it's 5 and not 4.